Today, our topic Introduction to Transistors. So this is comes under second unit. Today we will see in detail about transistors. So first introduction to transistors. So the basic electronic system nowadays is a semiconductor device, whether it is diode or BJT or FET or anything. So nowadays the electronic system is a semiconductor device. So the famous and commonly used of their device is BJT. BJT means bipolar junction transistor. Bipolar. What do you mean by bipolar? Bi means two. Polar means two polarity. Either majority polarity or minority polarity. So it can be used as an amplifier, logic switch, and also oscillator. So transistor can be used amplifier, logic switch, and oscillator also. So BJT consists of three terminals. One is emitter, second one is base, third one is collector. So two types of BJTs are there. One is PNP and other one is NPN. So BJT we are also called as transistor. BJT means bipolar junction transistors. Simply we call it as a transistor. Okay, we will see in detail about these terminals. So position of the terminals and a symbol of BJT. So before I am explaining this diagram, so briefly see. So this is a one type of material. So this one is, for example, P. Here, this is the P-type material. So it is a P-type material, two parts are there. So whenever other material like N-type material is sandwiched between the two P-type material, so sandwiched means in between, inserted into N-type material, then we call it as PNP transistor. Similarly, so it is a N-type material. So both sides here, it is a N-type material. So two layers are N-type. So in between, we are sandwiched to the middle of the N-type material with P-type. With P-type, we are sandwiched to P-type. Then we call it as NPN transistor. So you can observe clearly. So here one junction is formed because we know that PN junction diode means one P-type material, one N-type material, in between one junction formed, and one N-type material and one P-type material, in between other junction formed. That means here two junctions. This is one and this is one. Total two junctions. So already we know that how the formation of diode. Here also one N-type material and other is P-type material, in between one junction, one P-type material and one N-type material, in between other junction. So here also two junctions. That's why it is a bipolar junction transistor. So now I will explain. See these figures in vertical. So this is similar to, this figure is similar to this one, PNP. Just we are drawing in vertical. So these names we call it as, first one is emitter. This one is the emitter. So this is the emitter, P-type. Emitter. Other one is middle one is base. Last one is collector. So this one is emitter. This one is base. This one is collector. Similarly here also, this one is emitter, this one is base, this one is collector. So it is a three-terminal device. We can also call it as a three-terminal device. See, you can observe the circuit diagram or symbol of transistor. So this is a PNP transistor. So first terminal is emitter, base, collector. It is a 3-terminal device. So what do you mean by NPN transistor? So this is also 3-terminal. This one is emitter, base, collector. So only difference is this is the arrow mark. So arrow mark here entered in PNP, and in NPN it is outer. Outer means it is forwarded to outside. So this is NPN. So this arrow mark we call it as a conventional current direction. So in NPN this one, in PNP like this. Okay. So BJT is a, or transistor is a 3-terminal device. So this is the symbol for PNP and a symbol for NPN. So here only P and N, two different materials. So one junction is formed. N and P, other junction is formed. So two junction, 3 layers. BJT is a 2 junction and a 3 layers. Understood? So naming of transistor terminals. So transistor has a 3 sections of doped semiconductor. Okay. These sections, one side called as, this one is emitter, and opposite side we call it as collector, and in between it call it as base. Okay. So this is the transistor symbol. So in practically we will see in the lab. So this is the transistor. So in between one model wrote, it is a BC105, BC550, like that. One model name is wrote in that top of. So this is the flat section is faced towards the our face, and first terminal, left side terminal is emitter, second one, middle one is base, and rightmost side is collector. Okay, this is the symbol of transistor or BJT. So this is practically we will see in lab. This one, this is the kind of BJT. So this is the symbol. So it is a 3-terminal semiconductor device, BJT. Okay. So transistor construction, just I explained. So 3-layer semiconductor device consisting of, see, 2N and 1P layer of material is NPN transistor. That means what it means. So 2 layers, this one is N and this one is N, and 1P, this one is 1P type layer. So in between sandwiched. So this is 1P layer. We call it as NPN. Similarly, 2P layers. 2P layers means this one is P, this is one layer, this is other layer, in between sandwiched N type material. So this one we call it as PNP transistor. PNP transistor. Okay. The term bipolar reflects the fact that holes and electrons participate in the injection process into oppositively polarized materials. So here p-type material means majority charge carriers. We know that. What are the majority charge carriers in p-type? P-type majority charge carriers are holes. N-type majority charge carriers are electrons. Okay, electrons move from N to N. That means emitter to collector. Okay. So a single PN junction has 2 different types of bias. One is forward bias, other one is reverse bias. So 2 PN junction device has 4 type of bias. I will explain in this diagram. See, this is NPN transistor. This one is NPN transistor. First terminal is emitter, second terminal is base, third terminal is collector. Here also same, it is PNP transistor, emitter, base, collector. But we can connect the bias. Bias means adding battery to the device. Adding battery to the device, we call it as bias. So here bias means sorry. So this is the one junction. So emitter base junction, first junction we call it as emitter base junction. So VBE voltage is applied. It is forward bias. Why it is forward bias? This is the negative terminal is connected to the N. N is majority charge carriers are, what are the majority charge carriers? Electrons. So electrons having negative charge, here negative charge. So negative repels. So these electrons are moved towards or cross this junction, first junction. Then here poles. In p-type, holes are the majority charge carriers. So some electrons are recombined with holes and remaining electrons are moved towards the collector. Collector means it collects. So emitter means it emits the carriers. Base means based on, it is a lightly doped. Base means lightly doped means only less number of holes are there. So these electrons are combined with holes and remaining electrons are collected by the carrier. So this is the current direction. Okay, here also reverse bias. So emitter, so this junction, this one is emitter, this one is base. So emitter base junction is always forward bias and collector base junction is reverse bias. Okay, we can change these biases and we will see different characteristics. So first one is forward bias, reverse bias, forward bias and forward bias, forward bias, uh, sorry, reverse bias, forward bias and reverse bias, reverse bias. So four combinations, just I see. So two PN junction devices has four type of biases. Yes. So here two possibilities means four biasing. Similarly, PNP transistor also. Okay. So naming of transistor terminals. So our first block or first section, we call it as emitter. Our first, see, I will draw. So this one is emitter, base and collector. So this one is emitter, base and collector. See, the section of one side that supplies the carrier is called as emitter. Emitter means it emits the electrons or holes. Emitter is always forward bias. We are connecting always. For example, it is NPN transistor means, so it is negative. This is positive. Okay. This is a positive. This one is negative. Okay. So emitter is always forward bias with respect to base, so it can supply the carrier. So for NPN transistor, emitter supplies the electrons to the junction. Why it supplies? This is a negative electron. N-type material, majority charge carriers are electrons. So it is having negative charge. Negative repels means these electrons are moved towards the base. So emitter supplies electrons. These electrons are supplies to the junction. Similarly, p-type transistor emitter supplies the holes to the junction. Okay. See, you can clearly observe in size wise also. So this is n-type. This is the base and collector. See, emitter is in doping wise. Emitter is heavily doped. This one is lightly doped base. This one is moderately doped. Why emitter is heavily doped? Because it always emits the electrons to the collector side. So emits the electrons means it is heavily doped. Emitter is heavily doped, base is lightly doped, and a collector is moderately doped. So that is the doping concentration. So doping concentration for emitter is heavily doped, base is lightly doped, and a collector is moderately doped. So now we will see the sizes. So emitter is medium in size. This is emitter is medium in size. Collector is large. See, by seeing diagram, so large space. Collector is large space. Collector is large space means it is a collector size is large. Emitter size is medium. Emitter size is medium, and base size is very light size, means very small. Okay, that is the size. So this is the doping, this one is the size. So next, base. So the middle section which forms 2p-n junction between emitter and collector, we call it as base. What do you mean by collector? The section on the collector side that collects the carrier is called as collector. So emitter emits, collector collects the carriers. So the collector is always reverse bias with respect to base. So NPN transistor collector receives the electrons to its junction, and PNP transistor collector collects the holes, because PNP means emitter is holes. Majority charge carriers are holes, it emits the holes in PNP transistor. So collector collects the holes. Okay, some important factors to be remembered. So the transistor has a three regions named. One is emitter, base, and collector. So base is much thinner than other region. Base is much thinner than other region. Why? Why? Base is much thinner than other region. For example, this is NPN. NPN. So why base is thinner means if N emits the electrons, P contain holes. So if it is large in size, P is large in size, what happen? These all electrons are combined or recombined with holes. There is no charge carriers to cross the second junction, because all electrons are combined with holes. So there is no flow from second junction electrons. That's why this base is thin, so that only less number of holes are available. So these electrons are recombined with holes, remaining 95%. For example, 100%, 5% electrons are combined with holes here. Remaining electrons are crossed to the second junction and collected by the collector. Okay. Emitter is heavily doped, just now I told. So it can inject large number of carriers into the base. If emitter is heavily doped, then only it emits the electrons in a large amount. So base is lightly doped, so it can pass most of the charge carriers to the collector. It is lightly doped means what? Less number of holes. So less number of holes are there means these electrons are combined with holes, only few electrons. Remaining electrons are cross the junction and collected by the collector. So collector is moderately doped. Okay. So the junction between emitter base is called as emitter base junction. See, this is the NPN transistor. So first one is emitter, base, collector. So this junction we call it as, first junction we call it as emitter, emitter base. So emitter base junction or emitter diode. So this junction we call it as base collector junction or collector base junction. We call it as collector diode. So this junction we call it as emitter base junction or base emitter junction. This junction we call it as base collector junction or collector base junction. Okay. So the emitter diode is always forward biased. So this is forward bias. This is forward bias, and this collector base junction is always reverse bias. Okay. So the resistance of emitter diode is very small. Why it is small? Emitter diode means it is, this junction is forward bias. Forward bias means resistance is very small, current is high. And resistance of collector diode. Collector diode is nothing but collector base junction. So resistance is high because it is a reverse bias. Okay. See, you can clearly observe by imagining the analogy of diode, transistor can be construct like two diodes that is connected together or back to back. So it can conclude that the work of transistor is based on work of the diode. See, here we are one diode. This one is other diode, back to back connection. So one diode means one junction. Other diode means other junction. So this one is first emitter. This one is collector. Why it is so this is anode means here N, cathode means here P. Understood clearly? Anode means this is N and this is P, one diode. Here P and N. That means what? It is a NPN transistor. First one is NPN transistor. Second one is PNP transistor. Second one is PNP transistor. First one is NPN transistor. Second one is PNP transistor. Like that. Okay. Back to back connection of diode. So how it works? Transistor operation. So this is NPN. NPN. That means two layers are N. One layer is sandwiched in between two layers. Then we call it as NPN transistor. So this one is forward bias, this one is reverse biased. So VEB means emitter base junction voltage and collector base junction voltage. So whenever forward bias is applied, what do you mean by forward bias? So the negative terminal of the battery is connected to the N-type material. N-type is also majority charge carriers, electrons having negative charge. So this negative and this negative repels. Repels means these electrons are moved towards the base. So here P-type means majority charge carriers are holes. So these electrons are combined. Some electrons are combined and remaining electrons are moved across the second junction. So because these electrons are combined with holes means it constitutes the current, we call it as base current. So this is emitter current. Why base current? How it form? These electrons are combined with some holes. Remaining electrons are cross the junction. So it constitute recombination of electrons and hole constitute base current. And this one is remaining is collector current. So this is the thing. A forward bias in the emitter base junction causes electrons to move towards the base. This constitutes the emitter current. So these electrons are combined with base. This constitutes the base current and the remaining electrons are moved towards the junction, second junction, we call it as IC, means collector current. Okay. See, as the electrons flow toward the p-type base, they try to recombine with holes. Just I told. So a base is lightly doped. So only few electrons are recombined with holes within the base. Remaining electrons are cross the second junction. So the recombination of electron constitutes the small base current. Okay. So the remaining electrons crosses the base and constitutes the collector current. That means collector emitter current is equal to base current plus collector current. See, entering current IE is equal to leaving current IB and IC. So IE emitter current is equal to base current plus collector current. Okay. So this is for NPN transistor. Now we go for PNP transistor. Same, similar operation. What do you mean by PNP transistor? What do you mean by PNP transistor? So here two p-type materials. Here one and here one. Two p-type materials. In between, one n-type material is sandwiched. So two p-type material. In between, one n-type material is sandwiched. Then we call it as NPN transistor. So because it is a p-type material, it is a n-type material. In between, there is a junction. Similarly, it is a n-type material, it is a p-type material, different. So in between there is a junction. So here two junctions. So this junction we call it as emitter base junction. We know that first part is emitter, this one is base, this one is collector. So this first junction we call it as emitter base junction or base emitter junction. So this junction we call it as base collector junction or collector base junction. So forward bias. So we know that emitter base junction is always forward bias. So forward bias is applied to emitter base junction, and reverse bias, this one is reverse bias. So this one is forward bias, this one is reverse bias. So reverse bias is applied to the collector base junction. So forward bias is the emitter base junction causes holes to move towards the base. This constitutes emitter current. So how it happen? I will explain in detail. So this is the positive terminal. Okay. So this positive terminal is connected to the P type. So P type means majority charge carriers are holes having positive charge. So this positive is connected to here. Positive means it repels. Repels means these holes are towards the base. These holes are towards the base. See, it is a heavily doped means more number of holes are available in this emitter region because emitter is a heavily doped. So here n-type. So this is the base is lightly doped. Lightly doped means less number of, it is a n-type means less number of electrons are available. So this hole is combined with electron. This constitute base current because it is a less, for example here 10 electrons are there in base because it is a less or lightly doped. So 10 holes are combined with 10 electrons. So remaining electrons, that is, it is a heavily doped emitter. So remaining electrons are cross the junction and collected by the collector. Okay. So these holes, p-type holes, are combined with n-type electrons. We call it as recombination. Because of this recombination, it constitutes the base current. So here it is a lightly doped means only less number of electrons are combined with holes. Here electrons, it constitutes base current. Remaining holes are cross the junction and collected by the collector. This constitutes the collector current. Okay. So working of PNP transistor, at this holes flow towards the n-type base, they try to recombine with electrons. So a base is lightly doped, only few holes are recombined with electrons within the base. It is called as recombination. So holes are combined with electrons. We call it as recombination. Because of recombination, base current will generate. These combined holes constitute the small base current. So the remaining holes crosses the base and constitutes the collector current. So therefore, emitter current here also. Therefore, emitter current IE is equal to, so base current plus collector current. base current plus collector current in both cases. So in NPN same and PNP also same. Emitter current is equal to base current plus collector current. Okay. Till now, we will discuss the basic things of transistor. So let us briefly recapitulate or summarize. Please listen carefully. Okay. So transistor. What do you mean by transistor? Transistor is a three-terminal semiconductor device. Three-terminal semiconductor device. It consists of two junctions and three terminals. So each junction we call it as emitter base junction and collector base junction. So three terminals we call it as emitter base collector. Okay. So emitter is heavily doped, collector is moderately doped, and base is lightly doped. Why emitter is heavily doped? It emits the electrons or holes. So base is lightly doped. Why? Because these emitted electrons are cross the junction. That's why base is lightly doped. So collector is moderately doped because emitter emits, so collector collects the electrons, remaining electrons. Some electrons are recombined with base, so remaining electrons collected by the collector. Okay, so that is emitter base junction. So in size wise, emitter collector size is large because it collects all the carriers. So power dissipation is more. For that, area is also more for that purpose. And emitter is medium, size is medium, and base is it is very small. So emitter size is medium, base size is small, and collector size is large in size wise. In doping wise, emitter is heavily doped, collector is moderately doped, and base is lightly doped. Okay, this is the transistors introduction. So two junctions and three layers. It is a semiconductor device. Okay, this transistor can be used as a oscillator, amplifier, and digital logic switch. Okay, so these transistors can be operated in different ways because we have two junctions means we have to. So in transistor biasing we are using four ways. So first junction, two junctions are available. So first junction is forward bias, second junction is reverse bias. So that is one combination. First junction is forward bias, second junction is forward bias. Second combination. First junction is reverse bias and second junction is forward bias. Third combination. Fourth combination is reverse bias and the last junction, second junction is reverse bias. So four combinations are available. Because of four combinations, transistor is operated in four different modes. Okay, we will see in later. And what is the operation in a transistor? So NPN transistor and PNP transistor. First we will see NPN transistor. So in NPN transistor, so first emitter base junction is forward bias and collector base junction is reverse bias. So emitter base junction is a forward bias, we also called as emitter diode. Collector base junction is also called as collector diode. So whenever emitter base junction is forward bias means in NPN transistor, so electrons are moved towards the base and crosses the base junction, and some electrons are combined with the holes which constitute base current, and the remaining electrons are cross the collector base junction. It constitutes the collector current. Here total current is equal to IE is equal to emitter current is equal to base current plus emitter current. Okay. This is the operation of NPN. So it is similar to PNP transistor. Only thing is you have to remember here two junctions and three layers. How it form? With the two layers of P, one layer is sandwiched in between, then it forms two junctions and three layers. Okay, this is called transistor. This is the introduction of a transistor. Okay. Okay, thank you.